Earlier, we worked on solving systems of equation problems using one of three different methods: graphing, substitution, or addition-subtraction, also known as the elimination method. Now that we have the basics down for solving those types of equations, we will look at the practicality of solving them with some applied problems. Even though this is not a real practical problem, one that you would see in everyday life, I want to start off with it just to illustrate something. The sum of two numbers is 6. One number is 4 more than the other number. What are the numbers? If I wanted to go through and solve this, I would start off by deciding what I want x to equal and what I want y to equal. So I could say that x is the first number and y is the second number. Once again, I call this the labeling part, and I think this is very important. Then, based on the information, I could come up with two different equations. It says that the sum of the two numbers is 6. So one of my equations would be x plus y is equal to 6. I also could come up with another equation. It says one number is 4 more than the other number. So if I want to say that y is my bigger number, it doesn't really matter, I would say that in order to get y, I would have to add 4 to x. So I get y is equal to x plus 4. And then I could certainly go through substitution or addition-subtraction in order to solve that. But I want to graph this one just for one moment, just to show you one thing. If I'm going to go through and graph x plus y is equal to 6, I'm just going to set up a table of values. If x is 0, y is 6. If y is 0, x is 6. So I'm going to go through and I'm going to put those points on my graph. And I'm going to go through and I am going to graph that line. Notice that every single point that is on that particular line does satisfy that particular equation. Here's the point 4, 2, and 4 plus 2 certainly equals 6. Here's the point 1, 5, and certainly 1 plus 5 is equal to 6. Every single point that is on that particular line satisfies that equation. For my other equation, y is equal to x plus 4, I'm going to go through and I'm going to graph that one by putting a dot at 4, because that's my y-intercept, and then my slope is 1, so I could go up 1 and over 1, up 1 and over 1, or I could go down 1 and over 1 to the left, down 1 over 1 to the left, and once again I could go through and I could plot, or I could draw that particular line. Once again, all the points on that particular line satisfies that particular equation. Here's the point right here, negative 1, 3. If x is negative 1, negative 1 plus 4 does give me 3, so every point does work. However, there's only one point that satisfies both equations. And that one point that satisfies both equations is where they cross, and that is at the point 1, 5. So x is 1 and y is 5, and that certainly goes through and satisfies both of those. Here's a little bit more practical problem that can be solved with systems of equations. The perimeter of a rectangle is 78 centimeters. The length is 5 centimeters more than the width. Find the dimensions. Just like with any other applied problem, the very first thing that I do is I go through and I do my labeling part. So I need to know what the dimensions are. I'm going to say that x is equal to the width and y is equal to the length. And as I do all these problems, I always want to start off by identifying what x is equal to and what y is equal to. After that, then I need to go through and determine my two different equations based on the information in the problem. It does say that the perimeter of the rectangle is 78 centimeters. To go all the way around, I would need 2 x's and 2 y's. So one possible equation I could have is 2x plus 2y is equal to 78. It also says that the length is 5 centimeters more than the width. So if I have the length, that length is 5 centimeters more than the width. That would be another possible equation. Just like doing applied problems before, just remember there is more than one possible set of equations that you could write. Now that I have the two different equations, now I just need to go through and decide how do I want to solve them. Do I want to solve them by graphing? That probably does not make a lot of sense. By substitution or by addition subtraction. Since this has one of them already solved for y, I would probably choose to go through and solve this by substitution. So, since y is the same thing as x plus 5, I'm going to substitute that in for y in that top equation to create my third equation. So, as I go through and solve this, you can see that I get 4x plus 10 is equal to 78, which means that 4x is equal to 68. So dividing by 4, that must mean that I get x is equal to 17. Remember though, in the problem it said to find the dimensions. So if x is equal to 17, I'm going to come back to one of my original equations. That must mean then that y is equal to 22. So the dimensions of this are 17 centimeters by 22 centimeters for my final answer. Here's another example of a practical problem. A collection of 28 nickels and dimes is worth $1.95. How many of each kind are in the collection? Once again, the very first thing I would want to do as I go through and do this problem is I would want to identify what I want my x to equal and what I want my y to equal. And once again, it doesn't matter which one. So I might say x is the number of nickels and y is the number of dimes. But you could certainly change that and have it the other way around. Then I need to come up with my two different equations. I know that I have a total of 28 nickels and dimes, so one of my equations is x plus y is equal to 28. I also know that they have a total worth value of $1.95. So another equation I could write is 5 times the number of nickels, because every nickel is worth 5 cents, plus 10 times the number of dimes, because every dime is worth 10 cents, has to equal 195, because I have 195 cents altogether. So now I have my two different equations, and now I just need to decide how I want to go about and solve this. Because both of these are written in standard form, I might go through and solve this by the addition-subtraction method. So, for this very first one, I need to make sure that I have a coefficient in front of the x or the y that's the same. So I'm going to multiply that very first equation by 5. And that's going to change that equation to 5x plus 5y is equal to 140. The second equation stays exactly the same, 5x plus 10y is equal to 195. And then, since the coefficients in front of the x are exactly the same, I'm going to go through and I'm going to subtract my two equations. So when I do that, I get negative 5y is equal to a negative 55, which then tells me that y has to equal 11. If y is equal to 11, that means that I have 11 dimes. And I need to know now how many nickels I have. I'm going to come back to this particular equation, x plus y equals 28. If y is equal to 11, that must mean that x would be equal to 17, so I must have 17 nickels. One of the nice things with these applied problems is you can certainly go through and make sure that 11 dimes and 17 nickels is equal to $1.95. And it certainly is if you go through and check that. Here's another example of a problem dealing with finances. A financial planner invested twice as much of a client's money at a lower risk rate of 9.5% than at a higher risk rate of 14.5%. If the total first year's interest on the two investments was $4,355, how much was invested at each rate? If you could, I'd like you to turn this off and go through and do this problem and then turn this back on again and see how I might go through and solve this problem. Just remember, I might solve it differently than you just because I let different things equal x and y than you do. Okay, hopefully you've been able to go through and solve this particular problem. If I were going to go through and do this, I might say that x is equal to the amount at the lower rate. Now, I don't know if you did that or not. You could certainly say x is the amount at the higher rate. If so, you'll end up with the same answer at the end, but you'll get to it a different way. If I say x is the amount at the lower rate, I'm going to say y is the amount at the higher rate. And then I need to come up with my two different equations. One of the equations, it says that the financial planner invested twice as much of a client's money at the lower risk rate. If that's the case, I want to take 2 times the amount at the higher rate, and that has to be equal to x, because he invested twice as much of the client's money at the lower risk. This is the lower risk right here, so I have to double the higher risk rate to know what that is. So one equation would be x is equal to 2y. I also know that he got a total of $4,355 in interest, and he got that by getting 9.5% of the money he invested at x plus 14.5% of the money he invested at y, added those together and got $4,355. Now, I'm not going to keep those percentages. Instead, I'm going to change those percentages into decimals. So I have 0.095x plus 0.145y is equal to 4355. So you can see now those are my two different equations that I am going to use in order to solve this particular problem. Because I know that x is equal to 2y, I'm going to substitute 2y in for x in that second equation and come up with my third equation, which would be 0.095 times 2y plus 0.145y has to equal 4355. Now this is a kind of messy problem to solve as you go through, but I'm going to try and do so fairly quickly. I get 0.19y plus 0.145y is equal to 4355. Adding 0.19y plus 0.145y, I get 0.335y, which is equal to 4355. And then if I divide both sides by that 0.335, I get y is equal to 13,000. So $13,000 was invested at the higher rate, and I know from the problem that twice as much was invested at the lower rate, so that must mean the $26,000 was invested at the lower rate. Once again, you may have gone through and done that problem a little bit differently by reversing your x's and y's. But when you got done with the final problem, you certainly should have had these answers, $13,000 at the higher rate and $26,000 at the lower rate. As a summary, these are the steps I go through to solve. First, identify what x equals in the problem and what y equals in the problem. This is very important, and I call this the labeling part. 2. Create two different equations using x and y that explain the given situations. 3. Use either the substitution method or the addition-subtraction method to solve the problem. 4. When done, check the answers to make sure they make sense. I have all sorts of practice problems with the worked out solutions in this module that you can work on. Please remember, though, that just because I solved a problem a particular way doesn't mean that you have to solve it the same way. However, in case you get stuck on a particular problem, I thought it might be helpful for you to see one possible way for it to be solved.